This is section 2-3, graphing linear functions. The objectives of this section are to determine whether a function is linear, graph a linear function given 2 points, a table, an equation, or a point and a slope. And the vocabulary is linear function, slope, y-intercept, x-intercept, and slope-intercept form. Example 1 is to find the rate of change. Is it constant or not?
In example 1, you have to find the change in fx and the change in x. In other words, you're finding a pattern. On the top, you're adding 2 each time, and on the bottom, on fx, you're adding 3 each time. So the rate of change is constant, and it is 3/2. And constant means that it is the same. Then on example,
linear.
So the data is linear. And on example B, on the top you're adding 3 every time, but on the bottom, it is not constant because it is not the same number. So the data set is not linear.
In example 2, you are graphing using slopes and a point. You graph each line. The line with slope 2-3 that passes through 1, 1. Plot the point 1, 1, 1, 1, 1, and the slope indicates a rise of 2, so you go rise up 2, 1, 2, and you move 3 spaces to the right to find the run. So 1, 2, 3. Then you draw a line through the points.
Rise over run.
The rise over run. In example 2b, the line with slope -1/3 that passes through -2, 3. So like the same, you plot the point -2, 3 here, and then you go down 1 because it's a negative number, and move 3 spaces to the right, 1, 2, and 3, and you draw the line and you find the
to substitute x or y with a 0. In this case, if you want to find x, you have to put a 0 on y to only find x and leave x alone. Find the x-intercept of 2x minus 3y equals 12. 2x minus 3 times 0 equals 12. 2x equals 12. So therefore, if you divide 12 over 2, you have 6, so the x-intercept is 6. And then to find the y-intercept of 2x minus 3y equals 12, you have 2 times 0 minus 3y. Negative 3y equals 12. And you divide 12 over -3, and you have -4. So the y-intercept is -4. At the end, the point is x equals 6.
In this case, you multiply 2/3 times 2/3 y, so you leave y alone, and then you multiply 2/3 x and 3. 2/3 would be, so the equation would be y equals 2/3 x minus 2, because 2/3 times 3 is 2. It would be -2 because this is a negative and this is a positive. So then you graph the line. The graph of the line has a y-intercept of -2, so you have 1, 2 down, and then you move up 2 and 3 to the right because of the 2/3. 1, 2, and 1, 2, 3, and there's your line.
Example 5. Graphing vertical and horizontal lines. Example 5. Graphing vertical and horizontal lines. In example 5, you need to know that when you have x, the line will always be vertical, and when you have y, the line will always be horizontal. As you can see here, example 5a, you have x equals -3. So here you grab the point and you can see that the line is vertical. And then you have, for example, in example 5b, you can see that y equals 1, so you go up 1, you grab the line and the line will be horizontal.
Example 6. Suppose a road rises from 2,500 feet above sea level to 7,000 feet in 10 miles. Find the average slope of the road, graph the elevation against distance. Find the slope. The rise would be 7,000 minus 2,280, and that would be equal to 52,800. The slope is 4,500 over 52,800. It is equal to 0.085. Step number 2. You graph the line. The y-intercept is the original altitude, 2,500 feet. Use 0,2500 and 52,800, 7,000 as 2 points on the line. Select a scale for each axis that it will fit the data and graph the function. So in here you get the 2,500 right there, and you graphed it 0,2000 here, 0,2500. The other point, 52 points on the line. Select a scale for each axis that it will fit the data and graph the function. So in here you get the 2,500 right there, and you graphed it 0,2000 here, 0,2500. The other point, 52,800. 52,000 would go here, and 7,000 here, so it would be like right there, right in the point. And thank you.
So we hope you understand that our lesson,
and congratulate. We hope you can get good grades on this section.
yes.
Thank you.
Thank you.